So I can use Newton's cradle as an example of conservation of momentum, but instead I'm going to use Newton's cradle hitting this ball as an example. That is because the momentum from this ball does not disappear, but it gets transferred into this ball, which makes that ball move. Now, I could also use Newton's cradle as an example of conservation of energy, but instead I'm going to use this ball hitting the dominoes. Now, when I roll the ball, or if the ball was hit by the Newton's cradle, it would roll and it would hit the dominoes. Now, that does not mean that the energy from this ball disappears. It would get transferred into the dominoes, which would make the dominoes fall. Also, for conservation of energy, the energy is not created or destroyed, it's just simply transferred to another object. Now, Newton's second law is it's mass times acceleration equals force. So if the greater the force, the greater the mass, the more force and acceleration you would need. I experienced that a lot with this object, because to press the key, I needed a heavy object to be able to press enter on my computer. So I kept having to make this heavier and heavier. Now, to compensate for that, I would have to make this taller and taller, so the acceleration would be greater. And so then finally, when the tennis ball would roll, it would knock the hammer over, which would press enter on my key, and it would make the computer take a picture.